All right. Well, we've got two workshops, one in El Cajon, one in Tecate. Between the two, we're building about 600 and some odd guitars a day. They start with wood that we're taking out of various forests around the world. Here you can see some gentlemen cutting up a mahogany tree in Belize. Now, one of the interesting challenges as a guitar maker are some things are very traditional and some things need to be modernized. So here you can see our preferred modern mode of transportation. What's also interesting is if you look close, you'll see a little bar tag, a little barcode on the end of every one of those sticks of wood. Each piece is geotagged so we know exactly where the material is coming from. Now we'll bring that material back into our workshop, and here we're going to lay out, this is a piece of Hawaiian koa wood, we're going to lay out exactly where guitar-shaped blocks are going to come from so we can make best use of that material. Now we'll start sawing that material up on, in this case, a huge automatic resaw. We can cut upwards of 500 sets of wood, enough for 500 guitars a day. Other woods are built out of veneers to maximize the yield. Now this would have been done with perhaps a handsaw years ago, but it would take hours. Now there's me, I'm cutting up a top, but as a builder and as a designer, many of the instruments that I personally build don't have any tooling and they're not production friendly yet. I need the flexibility of working in a very traditional manner. Now once I say cut the top of a guitar out on my 30s era bandsaw, I know exactly what it needs to be. So I'll turn the rest of the work over to a laser program and a laser machine that can cut hundreds of those parts out every day to within an accuracy of 2/10,000ths of an inch. So I can count on exactly what that is. Other aspects, like in this case, I'm bending sides for a new instrument. I'm bending it the exact same way that a luthier or a guitar maker would have done 200 years ago. But once those sides are bent and the design is finalized, we'll start to produce an actual automatic bending machine that does the exact same task but can do it hundreds of times every day with utmost accuracy so that the sides of that instrument take on perfect shape every time. So you can see certain elements, well, there's a good old-fashioned way to do it. Like here I'm putting the interior strutting on the underside of a top. I'm using what we call a Japanese go-bar clamping system. It's been used for maybe 2,000 years. But nowadays, in order to bend and brace many, many of those guitars a day, we'll use a vacuum clamp that has a sheet of, say, a rubber film. That's what you can see here. A worker is gluing the braces, positioning them, and then folding this thing down and using vacuum pressure to snug everything up while the glue dries. Now, this is what we call voicing an instrument. In this photo, I'm actually giving the finished version, the finished shape, to all the critical components on the inside of an instrument. Well, naturally, that leaves a lot of variation, and it takes me a good deal of time to get that done. But using technology, specifically CNC technology, we can use routers like this one that mean 600 guitars every day are carved exactly as I originally intended them to be, without any variation whatsoever. So I know that one instrument is going to work great from one to the next. Now here you can see me losing my vision. I'm working on some abalone and mother of pearl inlay work. Traditionally, high-end instruments have been adorned as long as instruments have been around. But once I work out the design for an inlay or another element, I can use modern technology to replicate that piece over and over. So here you see that same headstock inlay, but being installed and replicated many times over in a matter of minutes instead of the hours that it used to take. Now here, I'm trying to keep all 10 fingers. This is a very old-style way of shaping a neck. Okay, now the neck is the part that a musician would actually fret on, and it needs to have a very exact shape. Now, if I'm building one, well, I'm going to do it that way. But if I'm going to build several hundred a day, again, I'm going to use computer-guided routing machines, because you'll see that I can load up dozens of necks, in this case 8, and take it from a rough blank to a nearly finished part in a matter of minutes. As well, this is a real tricky part of the guitar building process. Fitting the neck to the body, to the sounding chamber of the instrument. That's a process that traditionally took hours of very careful handwork with chisels, sandpaper, files. And even still, it wasn't that precise. Now, at Taylor Guitars, we designed a method for attaching the neck to the body using a system of removable shims, these little spacers, that give complete control and complete accuracy to the way that that critical joint is produced. It gives us the ability to do it many times every day. Some things, especially when you get close to the end of an instrument, like putting the strings on, it's still best to do it by hand. Eventually, we might use robots to do something like that, but there's still something very important with that last tactile play testing and the final string up and adjustment. Now, in this photo, you see 3 guitars. 2 of them, the one in the foreground and the one on the right, I completely hand-built using traditional methods, and the one on the left is the very first production article of the same design guitar. So that's what we do at Taylor Guitars. We make guitars, and it's a wonderful thing to be part of. Thanks so much.